Welcome back, guys. In this video, we're going to be solving these two equations on beta function. Now, please remember that I am picking some of my equations from the University of Benin. And I noticed that the equations are actually the same, just that for some years, they might just multiply by a constant. As you can see, these two equations are actually the same, but the lecturer kind of multiplied this one by 2. So it's not difficult at all. So what do we do? Let us start with the first one. So the first one says, we have the integral from 0 to 1, x to the 5, 1 minus x to the power of 4 dx. Now, this is actually much more straightforward. You want to compare this to this. So this is x to the power of m minus 1. This means that any power that x have is actually m minus 1. So this 5 is m minus 1. So m minus 1 is equal to 5. That means m is going to be 5 plus 1. So that's m equal to 6. Now, as you can see, this is looking like gamma function actually, because you always add 1 when you want to write in terms of gamma. So for beta, when it's of this standard form, you're always going to be adding 1 when you want to express it in terms of beta. Now, same thing is going to happen for n. This is n minus 1 equal to 4. N minus 1 equal to 4. So when you say n minus 1 equal to 4, this means n is going to become 4 plus 1. So n is going to become 5. So what it means is this answer is actually the beta of 6, 5. So let's express that. The beta of 6, 5. So this would be the gamma of 6 multiplied by the gamma of 5 divided by the gamma of, that would be 6 plus 5. Okay. So right now, this will become, what is the gamma of 6? That's 5 factorial. Gamma of 5, that's 4 factorial. Then this will be the gamma of 6 plus 5 is 11. 6 plus 5 is 11. So this will just be 10 factorial. There are times you can just leave your answer like this. But let's go forward. This is going to be a lot. So let's just see. Now, I'm going to leave 5 factorial like this because there's 5 factorial from 10 factorial. So I'm going to leave 5 factorial. This is 5 factorial times 4 factorial. That's 4 times 3 times 2 times 1. And for 10 factorial, that's 10 times 9 times 8 times 7 times 6 times 5 factorial. So that's what we're going to be having. Then 5 factorial, we cancel out 5 factorial. Okay. Then next, I know that 4 times 2 is actually 8. So that's kind of gone. Then 3 here is 1. 3 into this is 2. Okay, so at the top, what I have at the numerator, that's just 1. Then at the bottom, let's see what we're going to be having. This is 9, 7, and 2. 9 times 2 is 18. So what is 18 times 7? 18, 7. This is 6, 5. This is 12. Okay, 1, 2, 6. So times 10, that's 1, 2, 60. So that's the answer for this very first problem. That's the answer for the first question. Now, how about the second one? The second one is not difficult. Here's it. The second one. So we have the integral from 0 to 1. 2x to the power of 5, 1 minus x to the power of 4 dx. Now, we already know that the 2 is a constant, so we can bring it outside. So this is 2 with the integral from 0 to 1, x to the power of 5, 1 minus x to the power of 4 dx. Now, this is 2. This whole integral here was what we solved. This whole integral was what we solved. And the answer we had for that was 1 divided by 1260. That was the answer we had. So for us to finally solve this, we're going to cancel out. So this is going to become 1 divided by 2 here is 1. 2 into this should be 630. So this becomes the answer to that very problem. 1 divided by 630. And remember to hit the subscribe button, like this video, and share it across to your course mates. I'll see you in the next one.